Hello guys, this is a video where I would like to talk a bit about the super clipping of the CEL engine, which is a very curious set of flags and optimizers for the clipping process when a polygon is partially or fully drawn outside of the screen. It tries to terminate early the interpolation. Instead of interpolating every pixel and then checking that it's falling outside so it stops. And for example, here I was trying to understand how it works. I partially know how it works. And what's going on is that there are three types of clipping: normal clipping, line super clipping, and cell super clipping. If you never bother with enabling the super clipping, those two, you always get that one. Why? Because if you draw a polygon outside the screen, actually let me show you an example I'm trying to do in order to show how it works. I'm gonna make it now with red color is line super clipping, with blue is cell super clipping, but if I rotate it, if I take it like this, that's a mistake there, forget about that. So here it's rendered normally. This is the screen, but what do I mean render? This screen is in a certain video RAM address. If it was really rendering if it was actually rendering pixel, it would crash. Possibly. Because it would render outside of the video RAM in some random area. So, if you don't enable this super clipping flags, the CEL engine will still interpolate pixel by pixel. But it will just discard the pixel. It will say, oh, the pixel is outside of the screen, so better not render it. But it will do the work. It will do the whole interpolation. Okay. But if you go here, if you enable the line super clipping, it starts interpolating here. Starts interpolating like those are the vectors, the horizontal and the vertical vector for the orientation of the cell. It will start interpolating. It will see, oh, I'm inside the frame buffer. I'm inside, so I will render. Here, it knows that I'm outside the frame buffer, and the horizontal vector is pointing positively to the right. If during the rendering you are on the right side of the screen and the vector happens to point to the right side of the screen, you can nearly terminate. It's all these red pixels are not interpolated at all. At this line, it's cut. It stops. It starts rendering this line and stops. Goes to the next line, to the next line, to the next line. Maybe I should show that in a way. So in order to make sense of it, I might have to show you how, maybe by drawing lines, how the CEL engine is working. It starts, if you start on this position, you know what is this corner position? This corner position is the X pose and Y pose, horizontal source position and vertical is the corner position. And then you have the HDX, HDY, which is this vector. This is the HDX, HDY. Maybe I can write it. I don't know. SDX. That's a bit big, but okay. And that one is the VDX, VDY. I'm not talking about these vectors now, to simplify. These are the vectors that will, the third vector that will move this corner, so that you can make any kind of polygon. Let's simplify it. Let's see that we have the simple form of the cell quads that are rotated and zoomed sprites with some shearing, but it doesn't matter. So when the cell is starting rendering from here, it renders this line, starts rendering the pixel, okay, and it checks every time if it's inside the frame buffer. This is the edge of the frame buffer on the right side. So it renders, and if line clipping is enabled, it checks all the time. It checks at this point. Here now, at this point, it can easily check if my position is after the right side of the screen. It's over 320, you know, in a 320 by 240 resolution. And my vector goes positive. If my vector goes like this, but we have the vector, here is the vector, you know that I don't need to continue interpolating pixels and checking if they are outside of the frame. I can cut it. But I can cut this line and go to the next line. So it goes to the next line. Continues the same. It's terminating early here. Okay. And here, and here. So all these red pixels, they are not even interpolated, if you get what I mean. Now, let's run this again. But if you do it from here, forget this blue. This is a bug. Maybe have it like this. And I'm gonna do it like that. Maybe open a new one, I don't know. I'm just gonna do it fast. Because for a human, the human sees that, come on, the starting position is here. Here is the starting position. Where is mine? I know that this doesn't have to be rendered. But the line clipping doesn't kick in because this vector points inside the screen. The X position is on the left side, is outside, is smaller than 0. But this vector points inside, so it cannot predict. The way the cell engine works, it cannot predict that it can early terminate because it knows that if I continue rendering, eventually I will hit the screen. I might hit the screen. And look at this. Even here, a human being can see, come on, this is outside. You can discard the whole polygon, but the cell engine doesn't know because the cell engine says, I'm on the left side, I'm outside the screen, but my horizontal vector is pointing towards the screen. So it doesn't terminate, and it will forget about the blue. Now, only if you do it like that, the line clip. The red is the line clipping. This line super clipping. And if you do it like that, it will kick in. Forget about the blue because I haven't implemented, unfortunately. Here it's not gonna kick it. And now I have partially implemented the blend. What is the cell clipping? The cell clipping is that the cell engine could early terminate the whole cell. So if for some reason you render your polygon outside here, that's what the blue is. Here, maybe I can this the starting position is here. All the lines are rendering like that. You can easily predict that the starting position is here. It might not even need to check the lines. I'm not sure how this one works. But you can predict that the horizontal vector goes positive and upwards, and I'm outside, I'm in the upper side of the screen, and that vector goes there, but because we are above of the screen, nothing is gonna hit. It can predict. It can predict. Now when you rotate it, now it cannot predict, and it cannot even do the line clipping unless it does it there, even if it's outside. Because if you're like that, you might be outside here, this corner, but you might hit the corner here. You don't know. Here, the line clipping works here in those lines, here and here. And here that might be correct. Either this or this. The cell super clipping works. Okay. And the thing is that these are ways to early terminate either a bitmap line or the wall cell. And usually the one that matters more, you might think the cell super clipping matters because the whole polygon is, you don't even need to render at all, so it should be faster. But those are rare cases. If you are going to render a polygon that is fully outside, you can check the four corners and not even send the polygon to the cell engine. Don't call draw cells, or don't add it to your linked list of cells. So usually what matters is the line super clipping, because you might have polygons that are partially inside the screen and partially outside in your 3D engine. And this is where it matters for speed. Because else you would have to subdivide the polygon, and there are no texture coordinates in the cell engine, so you're gonna have a lot of problems. Unless you're doing flat shading. In flat shading, maybe you can skip it. You can do the clipping in the CPU in a way. But this is very helpful for performance for 3D engines. Although I might talk a bit about the issues that we're having. And if you don't care about those, there will always be some kind of clipping so that the cell engine doesn't render outside of the video RAM into some unknown territory and crash your program. But that means if this happens, maybe I'll run that once more. That blue is wrong. It shouldn't be cell clipped. So here, even with the line clipping and the super clipping, it's unnecessary doing work. Where is it? I lost it now. Sorry about that. This is annoying now. Alright. That means that it might be hard to show. This pixel is interpolated. It does calculation. It does interpolation. It goes pixel, 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 and then it discards. Says, "Oh, I'm outside. So sorry for doing all those interpolation for no reason. I was doing all this calculation outside of the screen, finding the grid points for, you know, the Maria stuff, those dot points, maybe even interpolating per pixel, and then deciding, I did all this calculation for nothing." It doesn't early discard. So your program will work, rendering will be correct, it will not crash, but it will unnecessarily do interpolations outside. But with the line clipping and the cell super clipping, it might early terminate this process at some pixels, which I've shown that the red pixels are not interpolated. It early terminates before the borderline. Also here, before the vertical borderline. And here it terminates the whole cell in these corners. And the thing with you see it here. This one, I think the position is here, and the vertical vector is there. It goes from here down to there, and this one is here. So it says if I'm in this corner, and my horizontal vector point to the right and up, and that points to the down and right. If it was pointing down and left, if it was rotated like this, it wouldn't work. Because if the bitmap was bigger, it could still hit the frame buffer. So here, this is totally cell superclipped, and this one, because with the specific positions and vector, there is no way it will ever hit the frame buffer. This one, even if it's outside, the line is superclipping, but it cannot discard the cell because that vector, you don't even see the vector, they haven't put it on the. That vector is pointing downwards. So if that bitmap was bigger, like this big bitmap, it could possibly hit the frame buffer. And here, this big bitmap, it goes. So this one, no matter how you, this is the one vector and the other goes like that. This is pointing to the right side of the frame buffer, and this is pointing down, but it's pointing down and right. If it was pointing down and left, there would be a possibility it would hit that. Like here, for example, this is not cell super clipped, but it's line super clipped because it goes, okay, this position positive. I guess discard this line, don't even, next line and next line. It realizes that the starting position of every bitmap line is on the right side, and it's gonna go to the right, so it's never gonna hit the frame. It goes away from the frame buffer. This one in the corner down is cell superclip, this one, and here it goes. From here it says, okay, from the starting position, this line will be discarded. I know it. I don't need to interpolate this line and this line. But when it reaches here, come on, this part is interpolated. No, it's interpolated, but it's outside, so it's still skipped. Normal clipping, so it doesn't render. But it has to do the work. This white triangle has to do the interpolation work, and then realize that I didn't need to do that. But then the left part, this part, it stops. And what I mean it stops, I guess you got it. It stops here. It stops here. This red thing is not interpolated. No work is done. It terminates on the green. But here, these parts are interpolated without being a need, because they were going to be outside. But it has to be interpolated. And then it reaches the frame buffer, and these are rendered here. These parts are rendered from the bitmap. And this is also, yeah, here's the frame buffer. And now, again, these parts, I guess you got it. You got it how it works. This is unnecessary interpolation because it cannot predict. So, and you have to understand that the whole normal line cell superclipping, it's this kind of weird thing where, depending on the orientation, it might work or it might not. So, if I have a sprite engine, maybe you could gain a bit if you can do it on CPU. If you move here, if your orientation is like that, the line clipping hits. But if the orientation was that, I hate that one. So the blue shouldn't appear there. It won't hit. But if it's like this, I told you, it's gonna hit here. So you could have an engine where maybe it's unnecessary work. If you have some sprites moving on the right direction, have the orientation like this. If your sprite moves towards that direction, flip, instantly flip, not rotate, to the other way. But then you would have to have double the amount of bitmaps, or so you could do strategies like that. And basically that's it. And there is something special with the super clipping and the cell clipping. When I tried to, the first time I wanted to try them, I wanted to enable them, I would have to enable those two flags on the cell. Enable the cell super clipping and enable the line super clipping. And I would go and do that. I enable both of them. I order the flags with those two. Also notice when I have the, I call this texture feedback type. This is for the feedback effects, frame buffer effects, where I can grab a video RAM frame buffer as a texture and and use it. You know, I can render on a cube a whole 3D scene that is rendered in another frame buffer. And I found out that when you enable the feedback texture, which is I think the LR form, the feedback texture, you have to change the preamble. You know, this needs a lot of work. You have to change the W offset or the height or other stuff. It needs a lot of work to get it working. Also, there are some helper functions which don't work exactly well. I found out that if I enable the super clipping, it would I would get the freeze bug always. Always. So for those kinds of textures, I would disable them. And I forgot an important thing, that as I was talking about the feedback, I diverted a bit. Yeah, so to enable super clipping, cell super clipping, and line super clipping, you would order your cell flags with these values, like you do with any other kinds of flags. But here's the thing, those particular ones will still not work. They will not be enabled totally unless you This is the exception. You also have to do something more for those ones. You have in the beginning where you set up your bitmap items and your bitmap and so on. You have to do that. You have to set that for both of your bitmap items. The ASC all. I guess SC is for super clipping. And you put all the bits to on. And that's something I didn't know because I was playing with those, I was enabling them, and I wouldn't see any difference. Not until I did this thing. You know. This is something good to know. But here's the thing now. Unfortunately, this feature, the super clipping feature, sometimes create a very bad issue. They create a problem with the renderer, and you might have some frames that freeze randomly. For example, here, where is it? Yeah, here. See how many tests I did. And this is something I investigate. I'm rendering a lot of random polygons on the right side of the screen. Oh, it froze. And it even tells you at frame 238. For some reason it froze. If you run it again, it's not going to be 238. It's going to be another frame. Even if it's the same sequence of random polygons with the same random seed. So there is a strange... It froze there too, and the video stopped. Maybe the video stopped. Here is where it froze. Yeah, see, at frame 908. And there is a very strange issue I'm still investigating because this super clipping is used in OpenLara, but it's disabled now, and it could give some advantage in the frame rate. And we're trying to find out what it is. It's a very strange hardware bug. Now, with Maui polygon tests, I realized here is where it doesn't happen. Now, I'm pausing the video so that I can talk because it's gonna stop. This one, it didn't froze, the video stopped. You can let it run for a very long time and it will never freeze. But then I tried this one and I tried various variations. Freeze at frame 74. 182. It freezes very frequently in this orientation. And as you have seen, I have made many tests. I have made tests that is crossing the vertical border of the screen on the left side, on the right side, with various configurations, various vectors. See how frequently. And finally, I was trying to figure out something, and I realized if you have a polygon, here is the starting position, and all these lines are line clipped at a later point, it's okay. But if you start to have line clip for partially for this line, this is the last example where it's skewed so that it goes to the right side. The vector goes gradually gets thinner and gets totally outside of the screen. And those ones that are fully clipped, when it crosses this line, it can produce the bug. And it can even produce the bug if your polygon is outside. But this vector points down so that the CEL superclip doesn't discard the whole polygon instantly, but the line superclip kicks in. and you have this back. But it is more complicated than that, because I thought the line clip was the issue. But it ends up being the cell superclip for my examples. So you could possibly, this is the cell superclip and this is the line superclip. You could just do that. You could do the line superclip, which is the most important anyway. It's the one that saves you from performance. And you might not have problems. But previously I thought that the cell superclip was okay. Previously I thought that this is okay. Not in my examples. I don't know. There is another. I don't know if this upper thing is considered to be cell superclip. Because previously, line by line, it will clip, it will discard at some point, and then it realizes, okay, this goes there and that goes there, so I can discard the rest of the polygon. And I will tell you why. Based on these examples, this is the thing I'm not sure. I would think that the cell superclip would be an entire polygon to be discarded. But here it says, if cell superclipping is enabled, a line superclipping has been applied to a source line of cell, the cell engine inspects the rest of the cell to determine if any of the pixels in the rest of the cell could fall inside the clip region. If no remaining part of the cell falls inside the clip region, cell superclip applies and the cell engine starts processing the next cell. It discards the whole cell. And that tells me, that might tell me something. Previously I thought, it's hard to explain. The cell superclipping would discard an entire polygon and only an entire polygon. Now here, this is line superclipping. Line superclipping, line per line per line per line. Is this kind. When it reaches that point, it knows that at this point, my horizontal vector goes there and the vertical vector goes there. So this one I don't need to go line by line by line. This whole region can be discarded. I can stop rendering this whole cell and go to the next cell. This is what that tells me. While previously I thought that a cell superclipping would happen only if you had this is what I thought, that if you have this, then the cell superclipping will kick for the entire, but not for a partial. But it might be that in these cases, this is definitely line superclipping, and this is cell superclipping. That might be the case, but unfortunately, all of these examples, they never show this case. They never show. Actually, it could be from here to here to here. Ah, but it goes down. See, it's not a good example. They always try to tell you that a complete cell will be discarded. A complete cell can be a cell superclip, but it can be a partial. Because here you say I will go line by line and I will apply the line superclipping. And you see line superclipping, yes, line superclipping. Cell superclipping, the cell superclipping comes on. So the cell superclipping even if I was thinking it might be that one, if the starting position as you go up moves outside and both of the vectors tells you that you don't need to do anything with the rest of the lines, just skip this polygon and go to the next polygon, skip this cell and go to the next cell. And why am I saying that? Because I realized in those tests this one, you see it's diagonal here because it's this case. In those tests, if I disable that, you know, what am I doing? Okay, sorry, it's so awkward. If I disable the cell superclipping, the cell only, actually what would happen? If you disable the cell superclipping, then the line superclipping will kick. If I disable the cell superclipping, the line superclipping will continue happening for every individual line. It will go line by line, but it will realize that from the beginning of the line I can just quit. So when there is a crossing from the line superclipping to the cell superclipping, we could see this diagram. We could maybe deduce why the bug is happening. So it goes, it tests bitmap line. At some point, it can realize, depending on the orientation of the vector, if we should continue line by line, or we can discard the rest of the polygon. But in the examples where it shows the cell superclipping, it's always discarding the whole polygon. They don't have an example where the case that a portion of the cell is discarded after portion of the lines, bitmap lines, are discarded. If you get me. Unfortunately, they don't have that because based on that, the cell superclipping is not just this example. It's example where part of the polygon can be. And that's why when I disabled the cell superclipping, I didn't have any problems in my tests. But here is the unfortunate thing. We are searching that in OpenLara for a long time. And in OpenLara, see the same code here. This was commented out to set the C controller as call to the bitmap items. I have enabled them. I say, no, it's not that. This is for another project. I don't have the code of OpenLara here. This is the line clip. If you just enable the line clipping in your project, maybe you will be okay. But unfortunately, I was trying some things with OpenLara, not very successfully. I tried to compile it and it still kicks in. The problem still kicks in. And I will finish with that. So we haven't found it. We have enough clues, but I'm not sure. And here's the thing. I don't know much about OpenLara. I don't know if I'm disabling cell clipping. I keep line super clipping, which is the important part for performance. I keep it on, and I still got the freezes. But I don't know if there is some code path that re-enables it, or some extra textures that re-enable it. Because maybe if you do a project, maybe just enable line super clipping. Or have an option menu to enable and disable in case the user has a problem. And only enable it if you have some project where your polygons draw outside. If all of your cell are going to draw inside the screen, like in a simple 2D game, for example, where you take care of not rendering outside the screen more easily, then you don't need to bother with that. But that is the mystery, man. That is the mystery. But now, this is interesting because I think this is a case where it switches from line superclipping to a sudden cell superclipping. And if you disable that, so everything is line superclipping, there is no cell superclipping. If you disable the cell superclipping, so if you don't do cell superclipping, it will go directly to no. Go to the next line. It will never go here to discard it. Do you understand it? That's interesting. With this diagram and the way I'm thinking now, it could give us some clue. Maybe why this is happening. When those two are interacting badly. At least in my tests, but not sure in OpenLara. And maybe that's the hint for OpenLara too. It's just that I have missed something. Something in the code path would still enable it for polygons I have missed, and I thought I disabled it for everything. This is interesting. So that's it. And oh god, this has put me into thoughts. But I think I have to stop now. I have discussed everything I would like to discuss about this whole kerfuffle with super clipping and the freeze bugs and how the hell this thing works. It's pretty complicated, as you see. It's simple, but yeah. Anyway, guys, that's it. I'll have to close the video and see you in the next video. Bye.